So what build are you in right now? That's
Hold on
the
a second.
latest.
So let's see, for people who are joining this live stream, we are about to review a bunch of visualization functionality intended for version 13 of Wolfram Language. Okay, Brett, you were about to ask something.
I was going to have you clarify which build you're using. Is it the desktop prototype build or is it a regular?
It's a desktop prototype build. Is that not right? I can
If
use
you've
the Mathematica
used that
builds.
one, which I think may still have some crashing issues, but is at least a day newer than your desktop one.
Okay. But I'm going to look at these things in documentation in the version 12.3.
Okay.
So is vector displacement plot, is that kind of a new thing altogether?
Yes.
Yes.
So this is a new way of displaying vector fields by how they act and transform a body.
As opposed to streams.
Yeah.
Correct.
So when you solve the origin of it is from solid mechanics. When you solve the sort of solid mechanics, you get a displacement field.
Yeah. A strain field. A strain.
No,
this is the strain field.
No. You get a displacement field. And from the displacements, you can compute the strain, and from the strain, you can compute the stress. But anyways, you get a displacement
I thought the
field.
strain field was the displacement field. What's the difference between a strain field and the displacement field?
It's an operator in between them.
Okay.
Okay, but this is also a general way of visualizing vector fields.
Okay. Yep.
By seeing what they do to a region, basically. So that's what we're introducing here.
What's this thing that looks like this is the 3D? Wait a minute, I'm confused.
No, that's 2D. That's showing the vector field in addition to.
I understand, but this, yeah. Okay, so let's take a look at this. What the heck is this? I don't understand. What's the gray thing?
That is the original reference region. So that is your -1 to 1, square corresponding to your X.
So if I said XY here, if I said the displacement is 0, 0,
they would match up perfectly.
Splatteroo. Okay.
Also good. Yeah.
Okay, by the way, that's the displacement field. So 1, 1, they would be offset like that.
Yep.
Right. Okay. So now what I want to do is I want to say, 1 over X, Y.
Yeah.
Okay. So if I say 1 over, this is kind of cool, by the way. I mean, I like these. This is, wow. You could make it like earthquake pictures or something with this. So if I now take, I see. So if I say sine 4x over x, and then if I say vector points, well, what happens if I just say automatic? Those are very hard to see.
Yeah, I think we're going to change the styling on them by default.
I would change them to. Is there a vector style here?
Set vector style goes to black and vector color.
Oh, I want to go vector style goes to white.
And set vector color function goes to none.
Well, that didn't work.
Set it to black because I think they're drawing in the back behind the thing right now.
Oh, I see. Well, they probably shouldn't be drawing behind it. Why should they be drawing behind it?
Yeah, I mean, it still needs a round of aesthetics, especially around when you draw the actual arrows.
So what happens?
Primarily good for small displacements, not like gigantic.
Yeah, I understand. Why does it have axes?
Often you need to exaggerate the displacement to show something. So for instance, we wrote one of these from the system modeler team wrote we developed a custom product a long time ago for SKF, which is the world's biggest ball bearing maker. In the displacement that happened in that steel is very, very stiff. So you need to magnify it by 1 million to even see something, because you get micron type displacements. And so it can go either way here. We need to magnify or minify displacement to make them show up, to exaggerate them.
I get it. I want to know why I don't have axes here.
I'm not sure.
Okay, just a bug.
In the latest builds, it's switched to a frame, which is what the other vector plots use.
I think it should be a frame. I don't think you want to muddy up the innards of the thing.
With filled regions, frames generally
I'm not
work
totally
better.
sold on the color scheme here.
Yeah,
I don't know what I don't have a better suggestion immediately, but this is cool. Points along. Okay. Okay, very nice. Okay, vector displacement plot 3D. That sounds pretty exciting.
I think the examples there are a little bit rougher, but
yeah, very nice. Okay, and so for the list versions of these, you are just giving a delta X, delta Y at every point.
Correct. Those pages don't exist yet.
Okay. Okay, so I mean, these are like the infinitesimal. Right. What's it? Oh, very nice. Very cool. There's a question on a live stream. Does it handle imaginary values? I would guess the answer is no, because it's plotting on. I see what you're saying. I see what you're saying. If instead of X and Y, you have the displacement be a complex number,
we can deal with that. We've done complex vector plot and so on. We can do a complex version as well of this if we want to.
Is it useful?
I think looking at complex fields as vector fields is kind of useful.
Yeah, I think so too.
So,
right. Well, I mean, basically, what this is a.
I mean, complex numbers are not really needed. They're just, a 2D vector field. Anyway.
But this is simply this is a way of representing what we otherwise have. We have these magnitude and phase type things, right? So we have something like what did I just do with my thing? Oh, here it is. We have something like complex plot. Well, let's just say complex plot of sine X plus IY or something.
Z.
Oh yeah, that's what I want to say. Z with Z going from minus.
Just say 3.
Yeah, just say 3.
What do you mean? Is that the unit circle? I mean,
no, it's a syntax you requested.
It's a square.
Yeah.
Plus or minus 5 in both directions.
That's a good syntax. Yeah, right. So this is one representation, but you could as well, that could equally well be one of your. I mean, what would it look like?
I mean, you could do complex vector plots.
Exactly.
Of that same thing.
Yeah.
You're saying that exists now?
Yes.
Since 12.2.
Because what's the difference between the displacement plot and the vector plot?
The vector displacement shows how it acts on a shape. See what I'm saying?
Okay. Mm-hmm.
And you normally don't even plot the arrows, so to speak.
I see. I'm not sure how important that is for the complex case. All right, let's keep going. Geovisualization. Geo Flow graph plot. What the heck is that? Well, we're about to find out. Oh, one of those. Oh, I've wanted one of those for a long time.
What kind of data do you want to use it for?
Well, I know Christopher had a use case for these. He was actually looking at commuting data between cities.
Mm-hmm. Yeah, that's a typical, traffic flows. There's commodity flows and import-export flows and immigration flows and all kinds of.
But I have a question. I mean, to me, a flow graph plot is itself an interesting construct without the geo aspect of it.
Yes. Yes. We have something in the works that's been in the works for a long time that we tentatively have called graph value plot. Because you can have values with nodes, with vertices, or values with edges. Like for centrality, you have values with vertices. And in this case, with flows, you have values with edges.
All right, so how are you specifying this? So you're specifying source, destination, and flow.
We probably need to support additional syntaxes.
And we do. I mean, if you have a graph with edge weights, then we'll use that.
All right, but you should also probably just have, let's see, what is the natural way to do this? I mean, it feels like source, arrow, destination, comma, flow is also seems useful.
I mean, this is so edge, comma, flow pairs.
Yes. Yes.
That's completely doable.
Right. But I would think.
I mean, I don't remember if we've implemented it yet, but we've also discussed using the 3-argument form of directed edge and undirected edge.
Well, that would be good too. Look, I don't understand. To me, it seems like there's a graph flow plot, which is.
I mean, we have one hidden in when you look at sort of flow is a core concept for graphs, and we've implemented it. And so there's sort of max flow and min cost max flow.
Yeah.
And in the data structures that come out, there is sort of a simplistic plot of those graphs that try to illustrate the flows. But we want to make it a more central concept, because there are all kinds of, the values that you have associated with both vertices.
Right. I think we have some things on the function repository for plotting functions on graphs, okay, at the nodes. Have you looked at those?
No.
Maybe you should.
Sure.
Let's see. I think there's one that has, it's called graph value something or other.
Yeah.
Oh God, I don't know where it is. This is so useless. Oh. Well, the good news is there's lots of stuff with graphs here.
Yes.
Huh, I didn't know we had that function. Huh, I could have used that function a few times. Some of these things we really have to look at moving into the where on earth is this? Graph function plot. Okay. So that's its way of doing that.
Mm-hmm.
Where's the function?
It's an association.
Yeah, where's the function? Oh. Yeah, no, I mean, look, we've looked at that, and every centrality value actually implements such a function under the application section. So.
Okay, but I'm saying that here this is a way of specifying. The reason I looked at this is a way of specifying. I see. So in this case, for nodes, it's basically specifying an association with the values for each node.
Right.
Right. Now here, with flows, you've got edges.
Yes.
I wonder whether you should also support something that is an association whose keys are the edge specifications and whose values are the flows. Do you see what I'm saying?
So edge specification as a list of vertices, or as like an actual directed edge, undirected
both.
edge?
I mean, both. You could support both.
I mean, I think that should be fine. I don't see any, uniqueness issues with association in that case. So,
right. But now, I mean, what you're doing here. Okay. So, what you have here is geolocations. Okay, there are three cases, in my opinion. There's the case where source and destination are coordinates in Euclidean space, right? There are cases where they are pure graph nodes that will be laid out according to a graph layout thing, where there's a skeleton graph.
So that is on the to-do list for our discrete computation team.
No, I understand, but I'm saying I think there are three cases, right? I think there's the case where these are geolocations, which is the case you've got here, right? And there's the case where those are simply XY locations. And then what you're doing is you're showing this kind of network between XY points. Maybe that's silly. I mean, maybe you don't need that, but I have to say, I would have to believe that would be useful. I mean, alternatively, you could say, build a graph, specify the vertex coordinates, and then do it from that, but you don't actually need the vertex coordinates. Do you get what I'm saying? So for example, I think a case that I know I've used is you have all those points around a circle.
Yes. No, we'll have more of these. This one is the geographic case.
I know that. I'm just trying to understand how the syntax generalizes.
But you're absolutely right. This thing of showing flows, if they're laid out around a circle, is an example of ways of showing flows. There's also something called Sankey diagrams, which is a very key sort of other way of showing both geographic flows and abstract flows.
That right. In some ways would be closer to the coordinate case, because you have specific layouts that you want.
Yeah.
Right. Okay. That looks quite nice.
It's a small graph. When they get bigger, they get trickier.
Yeah, I mean, the thing that's also concerning me is I can imagine node values being also important here. I'm a little bit concerned about the name here. Okay, I'm also wondering whether these are always straight edges, straight lines.
No, they shouldn't be.
I mean, they aren't always straight edges. I mean, in those cases they are, because there aren't any edges that are bidirectional.
The heck is this about?
It's just, all the, geo things are capable of taking geo positions in a variety of forms, including from the meta, information of images.
Okay. Okay, but what I'm thinking is, why isn't there a geograph value plot?
Right.
Which would both allow weights for the edges and allow weights for the vertices.
Yeah, Well,
and the way I would specify it is geo graph value plot would have this kind of, what I would do is I would have the first argument be essentially a graph structure where its typical signature would be, node, arrow, node, and then you could put it in a list like this, or you could put it inside the edge, what the weight is, okay? And then the second argument will be an association that gives the mapping from vertices to their weights, to their values.
I think we can maybe extend it in the future.
That's fine. I mean, that's fine. I'm not necessarily saying you have to do it today. I'm just saying I think it should be geo graph value plot. And I think the concept of a graph value plot is a useful concept.
Well, that we've had on our to-do list for quite a while for that.
But I like that name.
So Roger, how compatible is that with what you've had in mind for graph value plots?
No, that's pretty much compatible. We had a variety of ways of specifying the weights. Mm-hmm. I mean, you kind of want convenience so that the workflows come out right. So I think we need to be, for these plot functions, we need to be very flexible in eating different specs, basically. Mm-hmm. I do think that in terms of sort of common use cases, I think it's rare that you have both edge values and vertex values at the same time. It just
maybe.
I mean that
both cases are kind of important, though.
I mean, that
right,
said,
but then
Roger,
it degenerates nicely, because what you would get is graph value plot.
Mm-hmm.
What the heck is graph value plot? Wait a minute. What is graph value plot? Am I going crazy? No,
it's just use prototype build maybe, or what?
I don't know. But anyway, graph value plot.
It's been on our to-do list for a long time.
Okay, anyway, so I mean, what I'm imagining is, the thing is either a graph, and then the values here, vertex 1 goes to whatever, blah, 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 or this works kind of beautifully, because then this could be the explicit V1 arrow V2 arrow V2.
I think maybe just to be on the safe side, we'll make this guy experimental for 13.0 until we've sort of
which the geograph value plot.
Yeah. So we have enough time to sort of absorb and iterate on that.
No, I agree, but I think making a geograph value plot with this signature makes sense. And if you can't make it work with the nodes right now, then don't worry about it, but just make it work with we'll make it work with the nodes later.
Does that make sense? I mean, the other thing I was going to say, Roger, is the second argument there, at least for the flow case, could be an automatic type thing where it's the accumulation of the edge weights around a vertex in some way. Whether it's inbound or outbound.
I'm not sure that's particularly useful, but yes. But I would strongly encourage graph value plot. At the very least, somebody should put a function repository entry in for graph value plot for general graphs. But then the geo case is also what you built here. But if you can do it for the case of graphs, that would be even more wonderful.
Yeah,
seems not too difficult. I mean, it seems like you already have exactly all the technology to do this.
Yeah, I think that they're both important, and I think that the flow name is actually a really good name, because that's what you call them.
But that's why I'm taking it out, because I think we should also be able to put in vertices, because I think that's an equally important thing.
Yeah,
it's graph values. That's why I'm saying not flow, but graph value.
That's fine. That's the name I came up with myself a long time ago, so it's fine.
Okay, all right.
So that's why you see that name there.
Oh, okay, fine. So geograph value plot.
Okay. Can I ask a couple of questions?
Yep.
So go up to the diagram at the top because it'll be easier to see there. Do you think the color gradient is going in the right direction, or should it be flipped? And go dark at low
I think
flow.
it's going in the right direction. I think the darker. Look, this is a graphics question. If we want to talk about this, we should get Jeremy and so on here.
Yeah. I also think it's going in the right direction because when they're discrete things, the ones that are more, what you want is the higher value to be more visible.
Yes.
Okay.
So, however,
but I mean, this is doubly more visible.
Yes.
Exactly.
Right.
But presumably, you can have colors be separated from widths. How do you specify that?
So the colors come from a color function. The widths come from an option which doesn't have a doc page yet, which is called flow sizes, which is similar to bubble sizes, and so it's a scaled quantity off the size of the graphic.
You sure you don't want to call it edge flow sizes? Probably not. No, it's okay, probably.
As long as it's experimental, we can change the...
Well, let's not count on that. Experimental, just making things,
Yeah, okay, fine. I mean, even if it's not experimental, we can change option names down the road. But I'll think about the naming a little bit more, in light of the anticipated future direction.
Right.
Yeah, I mean, probably
because we're going to want a vertex size. That
it'll probably be like edge sizes and vertex sizes.
But we've already got a vertex size, so that's not going to work. See what I'm saying? Vertex value size or something is what it's got to be.
Okay.
Vertex value scaling, maybe, or vertex value function. I don't know.
I think sizes is sufficient.
But then if you say edge value sizes or something, or edge value size, something like that, I think that's better than flow because it might not actually represent a flow. By the way, this should work with an undirected graph.
Yep.
So it's not, well, there might be flow in an undirected graph, but it's less obvious. Okay.
So
yeah, anyway, so that name, just a second, the vertex size name.
We'll go with vertex value size, edge value size. I think that those are pretty good names. If you're okay with that.
Okay, I think I'm okay with that.
Yeah, I'm going to put an S on the end of them for consistency with the other options that are in that family.
Fine.
Can you go down to the method section in options? Or I mean, get there eventually, but
wait a minute. Method section in what?
In options examples.
Options examples.
Scroll until you see the Bay Area. Graphs that look different. A little bit further. Keep going.
Who built all this stuff?
I think Emmanuel did most of the example filling in. There we go. So we have some additional functionality that's in here that probably we should expose in some way. And I don't think Roger and
I understand.
Roger and I have discussed the functionality, but not how to expose it.
That's an issue. I mean, the bundling scale, that's an issue I can imagine with many, many, many kinds of plots. I mean, combine the points if they're really close. I can imagine that with feature space plot. I can imagine it with all kinds of things. It's a useful concept.
Yeah. We do edge bundling of these community graph plots and stuff. But here it's kind of important when you have complex plots that we do edge bundling, and we can imagine doing vertex bundling too.
Right. So this is doing vertex bundling.
Okay.
We haven't implemented edge bundling yet. It's just some coordination with Charles's team that hasn't come in yet.
Well, so it's like point resolution scale or something, or point something like that. It's sort of the resolution at which points are distinct. Min point separation.
Yeah.
That's an interesting take on it.
Seems like a reasonable way to do it, because that's something that's generalizable to list plot and God knows what else.
Mm-hmm.
We need to take a think of it then, if we want to, if you think of it as a very generalizable concept.
That's what I think, min point separation. And then you can have, okay, so that's min point separation. And then there's, well, this is really min edge value. Okay, what about something like min resolved point separation? Min resolved edge value. Oops.
No, I don't think that's how edge bundling is going to work.
No, this isn't edge, but this is minimum shown flow. It's just like there's nothing shown here, right?
Right. So that's
there were no chickens
basically a
walking
clipping
down
style
that road.
almost sort of thing. It doesn't show edges that are below some threshold.
Oh, I see.
Well, so really it's min displayed edge value. Min resolved point separation, min displayed edge value. Those at least make sense to me.
What does the resolved mean in resolved?
Well, it means it's.
I think you just mean min point separation.
Yeah, all right, fine.
But they seem different things to me.
These are different.
They are. I mean, they serve the same purpose of simplifying the appearance of a complex network, but they go about it completely different ways.
Oh, I see. That's interesting to be able to use scaled in there. So these are good options to have.
Right, and then I think there's a third one which I don't have examples of because the functionality wasn't working when we were working on the docs yesterday, which is that basically it has a threshold above min displayed edge value that controls if you have edges from A to B and from B to A, they may be large enough to show, but small enough that we don't necessarily want to show both of them and just collapse them into a single, yes, these two things are connected, but the flow between them is minimal.
Wait a minute, you're saying a lower bound for min displayed edge value. You're saying that it could be the min to display and then the sticking point, so to speak, below which you will not display. In other words, whether you display at the min value or not, or whether you display something else for anything below the min value.
let me send you a link real quick, which has an example that is maybe easier to think about. Actually, I'm gonna send you a screenshot because I don't trust you to have credentials on Stash and conveniently available. Where did that not?
Okay, well, as you're doing that, I mean, I think I understand the point. You want to have, really what you want to do is you want to have an elided, what to show if you're not showing anything.
No, you should have the email now.
Okay. But you understand what I'm saying, because what I'm saying isn't silly either. I mean, what to show if you're not showing anything, kind of thing. What is this now?
So here we have, a simple network, and we have flow, going to and from every pair of vertices.
Yep.
And so the flow, the concept would be that the flow between Des Moines and St. Louis, those thin purple lines.
Yes, I know what Des Moines and St. Louis are.
Yes, but not all of our viewers might.
I know. I was thinking that.
The concept.
It took me a moment to figure out where Des Moines was, but never mind. Go ahead.
So the concept would be that there would be a setting where, like, those purple vertices are above the threshold so that they display.
You mean purple lines?
Yes, those purple lines, sorry, are above the threshold so they display, but below a different threshold that would cause them to render as a single purple line straight between the endpoints instead of having the two going here and coming from there.
But then that is what Stephen said. Do you see what I'm saying?
Not quite, because this is a bundle. These are two undirected edges. I don't understand why there's a
those are two directed edges. They're just so thin you can't see the arrows at the end.
So wait a minute, you're combining the two directions into one line, or what?
Yes. So you'd effectively turn the two directed edges into a single undirected edge.
That does not seem like the most important thing to me. I mean, the question, I agree that it's a luxury.
Because we can leave that as a method option for now.
Yeah, I think
we'll promote the other two.
Right. I think this question about a min, if there is a connection, but it's too thin to see, what do you do? Which I think is worth having. Like, for example, I could imagine a dotted line between things if it's below the threshold, right?
So that's right. So what we would do there is,
actually, if you have a scaling function that determines the width, I mean, the difficulty is what happens if it goes below hairline width?
Yeah, actually, thickness is not that great. I mean, there's very limited bandwidth in thickness. So
yes, but what is your scaling for thickness? Don't you have? Isn't there a bubble scale? We do bubble charts. We have a whole scaling mechanism. Right.
What we end up doing is to go into opacity to get a bigger bandwidth, basically.
Okay.
And then you can do the other thing too, to have sort of a scaling function.
Right. I think we would support, the way to go we would support scaling functions, which would apply to the values.
I think we need to, yeah.
And then
we should have logarithmic flows, basically, and logarithmic sizes.
And then we would need some sort of range option.
Okay, I think it's got to be analogous to the bubble chart business somehow.
Yeah.
I think you guys need to think about this.
Yeah, we will.
Yeah.
I mean, we're going to have one more of these. Let us iterate and come back.
Okay.
One more round, because we can spend easily an hour or two on this.
Yes.
Yep.
Okay, let's look at geocontour plots.
No, so that's not going to make it. I'm sorry. This is going to be for the next iteration that we start using the. Yeah, that's what it's using now, but the future.
Switch over to be able to use. Yeah, whatever
whatever we call it.
Decided on.
Yes. Right.
Okay. All right, multi-panel plots. Boy, if I can figure out how to use these, I'm coming out way ahead because I find these super confusing.
Yeah. So I think that part of what we've been doing now is to, I don't know if that's made it.
I don't think any of the examples have been.
Okay, so tell me how to make a multi-panel bar chart.
Bar chart, a couple data sets, chart layout goes to row. You're gonna have to type row in.
But it will be in the autocomplete.
Yep.
Of course.
Okay. And how do I get an X scale here?
Those aren't hooked up in the build you're using yet. Okay. It would come through, chart labels, just like the normal layout.
Right.
I think you can look at list plot reference page because that one we've updated to be a little bit more helpful in the notes.
List line plot has the best docs.
Okay, list line plot. That's what I was looking for.
Yep.
We've not promoted them well enough. And there's
these chart layout things.
Yeah.
What happens if I have?
I mean, the multi-panel stuff is.
What happens if I have like a whole bunch of these? What happens if I copy this and I have like this? Can I have them in an array?
Not in an array.
Why not?
We have parsing problems when we go too deep because this supports wrappers at every stage and this.
Okay, but I mean, but that's what people want, right? Is some kind of array-like thing.
I mean, you can do an array-like thing.
You can do an array-like thing. Yeah, and
I mean, bring up the docs for list line plot.
Yeah, please.
Which have the best description of what the possibilities are at the moment.
Scroll down to after the options. There.
Are those options supported here? So if I do this, and I say chart layout.
I don't remember if like row 2 works in your build, but it does, within the last day or two. Okay.
And what happened to the headroom here?
We need to look into the spacing. There's generally some padding that's gone missing somewhere, so it's on our punch list.
Okay. And what happened to the 10 here?
It and the 0 went off and played hide and seek.
Okay.
I mean, basically the 10 and the 0 are, disappeared to leave room for.
Right, but I think you should have one of them.
Okay.
Okay.
And with the new, these aren't using the new axis objects yet. These are using an older way of constructing axes. And the new axes objects should be, there's a PR under review right now that will do tick removal, label removal to avoid collisions. So
All right. Okay.
We may not have to do it manually.
So do we have this? Is this working? Can I try this?
Sure.
This is our okay. So we're on. We're not finished with multi-panel. This is part of the rollout. There's many more rounds to come. Multi-axis. We're on the very first case. Okay. This is our first sort of multi-axis function.
This is probably going to be boring.
Pretty boring.
Completely boring. It's not completely boring.
Put a multiplier in front of one of them, or
I did.
No, you.
Why the heck does this only have 10? That's range of 10, and this one. I'm utterly confused here. Why are there not 7 second things?
I see. There's some issue with the horizontal range.
Oh yeah, my God, what happened?
I'll look into that.
I just have my bug fingers out.
Indeed.
Yeah.
I mean, I was happy when it took you 3 inputs to find something wrong with vector displacement plot. So
to
hit the 0 vector.
Right.
Okay, so do something that has the same length but different scales, same number of points. And
same so different, same number of points but different scales.
Right.
Okay.
And go ahead and add a third data set now.
Well, that was a kind of silly thing because I just need to say. That's pretty snazzy. That's pretty snazzy.
And now for fun, add range of 10 plus 1. Or 1 plus range of 10. I thought it was boring. Why did it do that?
What do you expect it to do?
What I expected it to do was something like put a list around multi-axis and do list 1 4, comma 2 3.
Yeah, I see what you're saying.
The other two don't have to be in a list. They can be on their own. Delete the open before the 2.
No, it's fine.
No, before the 2, delete the open brace.
Why did you want that?
Why did that? Try putting a list around the 2 and a list around the 3, but I didn't think that should be necessary in your build. Okay. Go back to just the string multi-axis and use reverse of range of 10 instead of 1 plus range of 10.
Okay. What's your point?
That is not what I was
expecting. Just tell me what you would.
So basically, there should be some automation that allows one scale to be used for multiple data sets.
I get it.
In which case the appearance looks a bit different because we basically put a little line swatch above the individual axes instead of.
But if Stephen did what he tried to do, grouping 2 of them and 2 of them, you would see that, right?
Yeah, except that wasn't working.
Oh. Okay, but in any case, right now you have the metaphor. I mean, it was a little bit, this, I didn't, this is cool, but how do you do it in a more swatchy way?
Yeah, the more swatchy way was what we were trying to show. And the swatchy way is that there's sort of a black axis and it has swatches of the colors that are, tied to that axis.
I'm sorry, say that again.
Maybe, can we create it, Brett, so we can just look at it instead of trying to explaining words? Because it's like visualization in words.
A notebook, and I'll just send it to Stephen.
Okay, good.
Edmund is commenting, could chart layout arrow multi-column be added to automatically select the up-tos with the row column value option?
We are thinking about that. Okay, email sent your way.
Oh my, we've got a will this bug ever be fixed? I hate seeing those kinds of things. Let's see.
What is that one?
Mesh style, red, black. Huh? Why isn't one of them red, one of them black?
Because it's mesh all.
So what?
I mean, so mesh style red, black means that it applies red to the first mesh function and black to the second mesh function.
Okay, how do you get red on one of these lines and black on the other?
I don't remember off the top of my head. I think there's, some way of doing it, but.
Well, okay, if we can find it, let's expose it. Be a good example. This would be, whatever the way is, will be a good example. Because it obviously hasn't been findable and you don't know it.
Let's see. Did you get the notebook I sent?
Nope.
Okay. Okay, so the one at the top is
see those line swatches basically.
So this is using, an internal function that is what's being hooked into list plots, but.
I understand, I'm thinking. So, okay, so what are the schemes? The schemes are, you've got the kind of, the medals here, or whatever they are. What are those things called? Those stripes people have on like military, what are those things called? What are those called?
I don't know.
Okay, anyway, I'm going to call these medals.
Decorations?
I think the other thing I just might tell you right now, which I think is in actual use would be very useful, but there's an implementation problem. I think it would be really nice if one could click an axis and de-highlight the rest of the curves.
Oh yeah, sure.
You know, so those curves that are tied to that axis stand out.
Right. But I think that we want something where you can also see it in, in this kind of form. I mean, I find this a little bit garish, this thing here.
Mm-hmm.
Yeah, I agree with you. It's a bit, I mean, it's not unuseful in the right context, but I don't think one could have it sort of everyday type thing. It's like too much.
I don't understand why you're not just using dots of color on the axis.
Sure.
Like just as a style. I mean, you could just have a little dot at the top there, or 2 dots in this case.
Like where the lines are, or like physically on the axis?
I would put it on the axis. I would just have it embedded in the axis. That's kind of like just like you would put a label on an axis. I would put, well, or you could just use it as a label. I mean, you could, look, an axis is vertical. Why not put these lines vertically on the axis here, like as a label, like in the label position? See what I'm saying?
It's possible. So like, where the, labels are on the position, but on the example below that.
I was thinking not there. I was thinking more tucked here, but
I mean, like having
like
it between the tick labels would be tricky.
All right. Well, so fine. So then I'm suggesting I mean, if we're going to do this, we should get Jeremy or somebody else from design, because this is not, I mean, let's use the best expertise we can for that. I'm going to have to leave soon, so we probably can't do that right now, but I'm going to suggest that you try these blobs here. I think that may look pretty good. Make sense?
I think it makes sense. I suspect they'll get lost or be confused with something
I don't know.
else, but
I don't know.
We'll try the experiment.
Why don't you try it? Okay, but these are lovely, and people have wanted this.
Yes. We're aware. That's why
forever and ever. I mean, there's an important thing.
It is.
And yeah, I see some questions from Ali here about same queue and compilers and things. Sorry, wrong meeting.
Yeah.
Different.
What do you think, Stephen? Half an hour or 1 hour more?
How much more is there here?
It's not that much, but you're going to want to sort of dig into it a little bit.
I think half an hour is going to be enough.
Okay.
That's what we go for now.
Okay. I assume that we're gradually burning down the plot types that we don't have. I mean, there's several of these that I've definitely, these are clearly useful, and they're just, for me, for example, some of these plot types are ones where it's sort of decreasing, it's a tail. I just don't know.
Yeah, I mean, so some of it is, burning, getting into the tail, and then, there's some stuff where it's sort of circling back around to.
Yeah, I mean, multi-axis has been so frigging requested for such a long time. Are there other things like that that have been very widely requested? I mean, some of this
probably at the top
stuff,
of the list.
Right. I would say that interactive graphics, like being able to click on curves and things, which we have coming, I hope. Right?
Yep.
That's part of the interactive graphics in the cloud integrated with the desktop. Yes.
Yes. We should discuss that soon.
Okay.
So
the other one that I just want to emphasize again is feature space plot is really useful, but really slow. And we need to figure out how to improve that, potentially parallelizing the feature extractor.
Right. I was going to say it should be the case that the slowness in feature space plot is dominated by dimension reduce.
Okay, well, fine. But then one of the points that's come up is, parallelization of that if you have multiple machines. Do you get what I'm saying?
Yes, but
right, we don't have a good way to do it.
You're talking to the wrong person.
Well, yes and no. I mean, then we'll need a meeting with everybody involved with feature space plot. If I can't get this, right, who's dealing with feature space plot? Isn't it you guys?
It is, but
we are
the dimension reduce part of it is a black box to us.
No, yeah, we're using the machine learning team as subcontractors. We're not.
Okay. All right. Okay.
Those
okay.
are,
then
in the
can we have a
chain.
brief 5-minute segment of perhaps the next visualization meeting where we bring in appropriate person from machine learning and we hash this particular thing out? Hopefully it's 5 minutes. Okay.
Is there somebody who knows an example that is considered slow?
Sorry, what? We can hash it out anyways. We don't even need, it's just, they need to make it faster. It's that simple.
Well, I know, but it requires, it's a syntax change to feature space plot and so on. It's going to require a parallelization option, et cetera, et cetera, et cetera.
Right.
I don't know of other places, and maybe there are ones, where plots might have sub-parallel maps.
Maybe, they can supply us with another function that we call that is parallel.
No, because I think you're going to need an option flowed through you're going to need an option flowing through from a feature space plot that determines whether it is parallelizing or not.
Right.
See what I'm saying?
Sure.
And I'm just wondering whether that same metaphor of parallelizing the raw material for graphics is going to come up in other places. Certainly comes up there. I'm not sure of other places it comes up.
I mean, I could see it coming up in other places. I mean, not necessarily. I mean, I don't think.
The truth is, it could come up in almost any. I mean, even plot could be parallelized.
I mean, it is. It uses a numerical function which automatically compiles, which uses parallelization.
No, it uses multi-threading. It doesn't use parallelization.
Yeah, parallelization.
No, it doesn't use.
That is parallelization.
It's a form of parallelization, but it does not use multiple machines. If you have multiple machines, it only uses threads on a single machine.
That's right.
Yeah. No, I was going to say we could probably add it as a 5-minute item to, was it the bi-weekly machine learning meeting or something?
Sure. Okay, that's fine. All right, a lot of lovely stuff here.
Okay. Good
and until the next time. And next time, let's get Jeremy to join us for a few minutes. Look at these things. Okay. Thanks and great stuff.
Thank you.
Okay.
Talk to you later.